could be seen here. This is the top view. It's a square of 40 mm dimensions, and front view is a triangle having height which is known to us. Now to draw the development of this pyramid, let we assume it is not cut anywhere. It is shown it is cut over here. If it is not cut anywhere, it is having 4 triangular faces, like, right? So develop its 4 triangular faces by taking its slant edge as a radius, like this. This is, you can name the endpoints. This is apex point O dash, this is point A dash, point A, point B, C and D. Endpoints are there. Similarly A dash, B dash over here, C dash and D dash over here. 8 points are there. Now taking O dash as a center, O dash A dash as the radius, like this. O dash A dash is the radius. Because OA, here this is OA is parallel to XY line. So O dash A dash represents true length of the generator or true length of the slant edge. So take O dash as a center, O dash A dash as a radius, and draw an arc like this. This is the arc. Taking O dash as a center, O dash as a radius, draw an arc like this. Right? Now take side length as a radius, this side length. OA as a radius, A dash as a center, cut on this arc 1, 2, 3 and 4. So we do have 4 points over here. A, here is point B, here is point C, point D and back to A, like this, and join all these points with a straight line such that we can form 4 triangles like this. So this shows the development of square pyramid when it is not cut anywhere, like this. So 4 triangles would appear, all are joined with the slant edges. Now if I unroll the outside surface of this pyramid, it would appear like this, unfolding of this outside surface. Now what's about this cut portion? If it is not cut, this is the development. Now think about this cut portion. So for that, let me pick up 1 point. So this is 1 point. 1, 2, 1, 2. Similarly, 1 point is here. So for that, let me transfer this point. This is the point of intersection of cutting plane and a pyramid, like this. Similarly, from this point, draw a generator or imaginary edge like this. From this point, join to O dash and draw a line like this, and draw this generator in top view. So for that, transfer this point to its top view like this, and join this point to apex point O and this point to apex point O. Now to locate this point in this developed portion, let me name this point as point number 1, this is point number 2, this is point number 3 and this is point number 4. So what's about point number 1? So for that, point number 1, measure this distance. It is between A and B. Point number 1 is between A and B, and this is the distance between A and 1. So measure this distance. From A, mark an arc over here, and here the point number 1 would be there, somewhere here. This is point number 1. You can see here. Join that point number 1 to an apex point like this. So it would appear like this. Now point number 1 is here, point number 2 is here. So locate point number 2 over here, measure this distance. Point number 2 to A, measure this distance 2 to A, and cut over here 2 to A. So it would appear somewhere here. So here is point number 2. Point number 2 is known to us. Now we have drawn the generator from point number 1. This is the generator. Now this is the point on generator. So transfer that point to the true length somewhere here. take O dash as a center, O dash to this transferred point as a radius, like this distance as a radius, right, and draw an arc. This arc will cut this generator at one point. Here is point, so name it as point number P1. Here is the point. Similarly, this point is on O dash, B dash and O dash, D dash. So draw horizontal line from here, pick up this point, take O dash as a center, O dash to this point as a radius, draw an arc, and that arc will cut B, OB and OD at 2 points, OB at this point and OD at this point. So we have picked up more 2 points. Now join these points with a straight line, because no curvature shape is there in this solid. Join these 2 points with a straight line and join these 2 points with a straight line. So this is the developed portion of this the one triangle. Now what's about this BC portion? So between B and C, here also cut portion is there. So with the similar analogy, draw vertical line from this point like this. So this is point number 1 point is here, say point number 5 and point number 6. You can name the points. Point number 5, this is point number 8. Transfer this point number 5 and 8 on B and C. Measure this distance B to 5, right? Measure this distance B to 5, B to 5. So mark point number B, point number 5 over here. This is point number 5. This B5 and B5 distances are same. Now point number here is the generator. So this is 1 point. Now what's about this point? For this point, draw imaginary generator like this. Transfer that point to its top view and join this apex point to this like this to show the top view of the generator like this. Now here says here is point number 6 somewhere here, and here is point number 7. So transfer point number 6 and point number 7 on the development B6. So B6 somewhere here, here is point number 6 and here point number 7 would be there. So join this generator like this. This is the generator, and here one point would appear, that would be here. So join that point with a straight line like this, and join these points with a straight line and these 2 points with a straight line as well like this. So this portion is the developed portion. With a similar analogy, draw development on this side, and the development would appear like this. The same steps should be repeated on that side, as it's a mirror image of the problem or mirror image of the solution drawn by us in the first stage. So this is the final development of the given pyramid. This portion would appear from here to here as shown by black colored portion. You can write here it's a development. In examination you have to write answer like this. This is the development. If scale is changed, you should mention appropriate scale. You insert its height, whichever height is given to us in this data like this. Height which is given to us in this data is 60 millimeter. So write 60 like this, and it's a square. You can write it's a square of size 40 millimeter like this, and square dimension is written like this, SQ40 means it's a square. So this is the solution of the problem, which is also shown over here. In the screen it is given the final solution of the problem. This is the solution. Development of given pyramid in figure number 1. Now next question. This problem is asked for 7 marks. Question number 2b in option or. Draw the development of given cylinder in figure number 2. Here the cylinder is given of diameter 50 millimeter, height 60 and 25 SQ, means there is a square hole of 25 mm side length. How to draw development of this cylinder? The diameter is given to us. If you open the outside surface of the cylinder, the total width of the development would be width equal to the periphery of this circle, that is 50 means pi into d, that is 50 into 3.14, that is 157 millimeter. So width of the rectangle would be 157 millimeter and height would be 60 millimeter. So that would appear like this. This is the data given to us, and if you want to draw the development, its development of the cylinder would appear as a rectangle like this, having height is equal to the height of the cylinder, that is 60 millimeter, and width is equal to the periphery of the cylinder, that is equal to pi into d. If I open the outside surface, the width would be 157 millimeter, that is equal to pi into d, pi into 50, that is 157 millimeter. In examination you should write this calculation in the drawing sheet also, so that the examiner would realize that you know the basic concept behind the development of the solid surface. The width is 157 millimeter like this. Now to draw the development of this cylinder, let me divide this circle into equal number of parts. It is divided into 8 equal parts, say A, B, C, D, E, F, G and H. Similarly, its projections in front view, A dash, B dash, C dash, D dash, E dash, F dash, G dash and H dash, and divide this rectangle into 8 equal parts as well, like this. First divide into 2 equal parts, then again divide into 2 equal parts like this, again divide into 2 equal parts. So total division of the given rectangle into 8 number of parts would be like this. So we have divided the total width into 8 equal parts like this, 8 equal division of this. Now name the end points. Say this is point number A, point number B, C, D, E, F, G, H and back to A. Now to find out the points of intersection of this cut portion, let me pick up the points. This edge comes on H and B itself directly. So from here draw a vertical line on H and B. So on H and B, B means here. So from this point draw a straight horizontal line that will cut B at one point somewhere here and H at one point somewhere here. So 2 points known to us. Similarly, this point and this point are on C and G. You can see here, this is point C dash or C, this is point G. Here this point is on G and C. So from here draw a straight horizontal line that will cut C at one point somewhere here, this is C, and this point at C somewhere here. And to locate the G, from here draw horizontal line on G, one point is here, on G another point is here. So these are the points of intersection on G. Now what's about this point? This is on D and F. One point is on D, one point is on F. On D and F. So from here draw horizontal line, 1 to D and to F. F is here. So here is another point. So four points we have identified. What's about the intermediate point? We can locate the intermediate point by using the basic concepts like this. Let me take one exercise. So for that, divide this GH or BC into equal number of parts. So draw this line, divide BC into 2 parts. Similarly, GH into 2 parts. So we have drawn 2 more imaginary generators. From these points, draw straight vertical lines like this that will cut this cut square at 2 points, one over here, another over here. This point is between B and C. So mark between B and C, mark a point M. So this is point M. So midpoint of B and C is point M. From M, draw straight vertical line like this. And from these 2 points, draw horizontal lines like this. Straight horizontal lines. And they will cut at 2 points somewhere here. So we can have 2 more points. Similarly, divide this CD into 2 equal parts, say point number N. So point number N somewhere here at the middle. From N, draw vertical line or generator of N. From here, draw straight vertical line like this. It will cut the square at 2 points, and from these 2 points draw horizontal lines. So again we do have 2 more points like this. Now join all these points with smooth curve. So it would appear like this, and all the points should be joined with the smooth curve, as it's a cylindrical surface is there. So this is the development of given solid. This is one side. With the similar analogy, we can draw on this side, and the development would appear like this on this side as well. A smooth curvature shape would be there, a symmetrical portion on this side also, like this. And this is the development shown by the black colored sketch pen. These outer edges would be fully visible. Only these 2 portions would appear as a cut portion like this. Now to draw this portion in top view, we can show it like this. It's a square hole, so we can draw a dotted line like this to show the square edges. Here also a dotted line from this end to this end like this, and dotted line from this ends. It shows the edges of the square hole in top view. And this is the answer of given problem. You can write here, it's a development. Question number 2B, or asked in option for 7 marks. I hope it's clear to you. This is the solution of the problem drawn over here. Width is 157 millimeter, which is to be shown